Hello, everyone. We are going to be covering 8.1 polar coordinates today. Hopefully, you are keeping up with the homework. Okay, so 8.1 polar coordinates. Okay, so as opposed to rectangular coordinates, which you're probably more used to, x and y. Okay, so let's just look at the differences here. So rectangular coordinates, these are the ones you should be familiar with. Okay, so this is your traditional XY Cartesian plane. Okay, and you're usually given a point, an X component, and a Y component. So something like 3, 4. And to graph that, that's the X component is 3, the Y component is 4. So you go 3 on the X and 4 on the Y. Okay, so now what we're dealing with here today is polar coordinates. Okay, and what happens here is you are given a point, not x and y, but r and theta. And so what these represent are the radius and the angle. Okay, and so what happens here is you have these circles. And so that first circle has a radius of 1. The second circle has a radius of 2. This third one has a radius of 3, and it keeps on going. This one has a radius of 4. I'll just do one more. And this one has a radius of 5. Okay. And what happens is if you're given a point with a radius of, say, 3, then you would have to go out to the third circle. Okay. But the question is, well, okay, fine. I would go out to that third circle, but where on that third circle would I have to plant myself, right? So that's where the angle comes in. So what happens is you're given, you split up your circle into 360 degrees. So there's 0 degrees. This is 180 degrees. Okay. And then, of course, this is 90 degrees. Okay, and 270 degrees. And we can keep splitting it up if we do this. This one here is 45 degrees, and this one down here is 225 degrees. And over here, this is 135 degrees. And this one here is 315 degrees. So these are just some particular angles that I will label here, but we have all the angles between 0 and 360, and then some, because all of the angles will be coterminal with the angles from 0 to 360. Okay. All right. So suppose that I have this point, something like 3, 50 degrees, right? So this means you have to try to imagine yourself standing at the center of the circles there. So if you're standing there, you have to decide, okay, well, which way am I going to turn and face? So this angle 50 tells you, okay, so whatever you're facing right now, go ahead and turn and face 50 degrees. Okay, so that would be just past 45. And then this here 3 would tell you how far to march. Since it's positive, you would march forward. And if this number is negative, then you would march backwards. Okay, so we would face 50 degrees, and then we would march forward 3. And each circle is 1. So you would march to the third circle, 1, 2, 3. So 50 degrees with a radius of 3 is like right there. Okay. So again, this 50 means to face 50 degrees. And this 3 is like march forward. Okay. If negative 3, then march backwards. Okay. So this is what we're dealing with now. We're dealing with polar coordinates, where you're given a radius r and an angle theta. All right, so let's just kind of take a look at plotting right here in the polar system. Okay, so for example, if you had to plot 4 comma 3 pi over 4, why don't you go ahead and try that? Okay, go ahead and draw your polar system. And then figure out where you're going to plot that point. Okay, so you can go ahead and hit the pause button. I'm just going to be working on this, and then go ahead and come back and see if we have the same answer. Okay, so here is my angle. My angle is 3 pi over 4. Let me go ahead and draw some more angles here. There's pi over 4. Pi over 2. Pi. Five pi over 4. And then this one over here is 3 pi over 4. This one is still 3 pi over 2. And this one is 7 pi over 4. Okay. All right, so we need to stand in the center of the circle and turn and face 3 pi over 4. So we turn ourselves, we face 3 pi over 4, and our radius is positive 4, so we will march forward along 3 pi over 4. March forward instead of backwards. Negative 4 would make us march backwards. Okay, so we're facing 3 pi over 4, which is right over here. Okay, and we need to march 4 forward. 1, 2, 3, 4. Okay, so that's where your point should be. Just kind of note here that there are other ways to name this exact same point, just because if you add a full circle, 2 pi, to your angle, you'll land in exactly the same spot. And same thing if you subtract a full circle, 2 pi, from your angle, you'll still land in the same spot. Okay, so note there are other ways to name this point. And I'm just going to list a few. Okay, so if I add 2 pi, okay, that's 8 pi over 4. then I would get this angle, 11 pi over 4, right? And I would keep the same radius, okay? That would go full circle. Another way to do this is if I face 7 pi over 4, which is down here, 7 pi over 4, I could face 7 pi over 4 and march backwards along that line, in which case my radius would be -4. So this is also another way to name that exact same point. And then if I add a full circle, if I add 2 pi to this angle, then I would come full circle facing 7 pi over 4, but that angle would now be 15 pi over 4. And I would still need to march backwards to end up in quadrant 2 over there. Okay. Another way to do this is if you take 7 pi over 4, okay, and add a half circle. So if you add half a circle, okay, that would be pi. So if you do 7 pi over 4 plus pi, okay, then you would end up with 7 pi over 4 plus pi. Oh, actually, that's actually the same one. Let's do 15 pi over 4. That'll be more interesting because we already did this one. Let's do 15 pi over 4. And if we end up adding a half circle, pi, right? Then if we have 15 pi over 4, which is coterminal with 7 pi over 4, right? Okay, so if we add a half circle, then we end up facing 3 pi over 4, right? But that would be called 19 pi over 4. Okay, we would be facing that direction, which is 3 pi over 4 on our drawing. And so we would need to march forward 4. Okay, so again, these are just different ways to name the exact same point because now we're circular and we have many, many angles. Okay. So, in this section, we're going to take a look at how to convert back and forth between rectangular and polar. So we're first going to look at how do you convert rectangular coordinates, like an XY point, into polar coordinates, okay, into an r theta. How do you change XY to r theta? And then we'll look at rectangular equations, and we'll take a look at how to convert those rectangular equations into polar equations. Okay, so rectangular to polar. Okay, so before we go into the conversions of rectangular to polar, polar to rectangular, let's recall some things we learned in the previous chapters. So let's recall that sine theta equals y over r. Okay, so therefore y equals r sine theta. Okay, so this is going to be one that we're going to be using. Same thing with cosine theta. Cosine theta is x over r. And if we solve for x is equal to r cosine theta. So this is going to be another one we're going to be using. Okay, and then we also know that tangent is sine over cosine, which is the same as saying y over x. Okay, so this is also one we will be using. And then also, if you remember, r is equal to square root of x squared plus y squared. Okay. This comes from the equation of a circle centered at 0, 0. Okay. So this one here, this tangent one, we will be using this one. To find the angles. Okay. So here we have 4 equations that show the relationship between theta, r, x, and y. And so we know from rectangular coordinates we have x and y. So if you need to find x and y, you can use the 2 on the top. And polar coordinates use r and theta. So to find r and to find theta, you're going to use the 2 on the bottom. So really over here, to find theta, you would do the tangent inverse of y over x. And this will give your theta, but you'll need to make adjustments. Okay. So, because remember tangent inverse, your answers are going to be angles. And if you remember from inverse trig functions, tangent inverse is only going to give you positive angles that are in quadrant 1 and negative angles that are in quadrant 4. Okay, so if your angle is supposed to be an angle that's in quadrant 2 or 3, then you're going to need to make adjustments. Then what you have, if you take the absolute value of this, right, of the angle, what you'll end up with is the reference angle. Okay. All right, so let's take a look. Let's go ahead and start with a point. Let's take a point, a rectangular point, xy, and let's convert that to a polar point. Okay, so in this section, really, really pay attention to your location. Always know your location. Okay, so let's go ahead and plot -3, 1 just to see what quadrant we're in, because remember the angle when we use tangent inverse is not going to give us angles in quadrants 2 and 3. So let's have a look. All right, so -3, 1, -1 is down here. So you'll see what I mean when you use the tangent inverse. So we're here, we're going to be an angle, and it's going to have to be more than 180 degrees, right? Just past 180 degrees. So we're going to need to find that angle. All right, so polar form is r theta. So we're going to need to find r and theta. Okay, and all we know is x equals to -3 and y equals to -1. Okay, we have a formula for r. It's right there. R equals the square root of x squared plus y squared. So we can get the radius easily. Okay, so let's go ahead and plug in for our x and y. Okay, so we get that r is square root 10. Okay, so far our answer is going to be this, r theta. So far square root 10 something. Okay, so we don't know what the theta is yet. Okay, so according to this, we're going to use this formula right over here. tangent inverse of y over x equals theta. Okay, so let's go ahead and y is -1, x is -3. And then when you punch this into your calculator, when you punch this in, if you're in radian form or degree form, when you're in degree form, you'll get 18.43 degrees. Okay, so this is what I'm talking about. Okay, so here 18.43 degrees is in quadrant 1. That's just not much far from 0 degrees, right? 18.43 degrees. Okay, so what you have here, so 18.43 is like around here somewhere. This is 18.43 degrees. That's not the angle that we want. We want the one that lands here, right? So what you have actually is this angle, 18.43 degrees. Okay, so in order to find the actual angle, the actual angle, let me get a different color here. The actual angle is this angle here that is more than 180 degrees. How much more than 180 degrees? 18.43 degrees more than 180. So right here, this piece in here is 18.43. Okay, so this little piece. So here, this is the adjustment that I'm talking about. So that's why it's important to always know your location. So your actual angle is going to be 180 degrees plus 18.43. Okay, so this is going to be 198.43. Okay, which makes more sense. So this here is your polar form of the equation, of the point. Okay, so you started off with xy, and this here is now our theta. Okay. Let's take a look at some equations. So let's go ahead and convert to polar form. Okay. And suppose that you have this equation. Okay, so here we don't want any x's or y's. Okay, by replacing them with some equivalent of r and theta. Okay. All right, so x squared plus y squared. So let's go back to our equations at the beginning here. X squared plus y squared, we see that right here. X squared plus y squared, if we square both sides, so x squared plus y squared would equal to r squared. Okay, so then when we do this, we could replace these guys with r squared. Okay, so that takes care of those x's and y's. But now I got to take care of that x. Okay, so that lone x. Well, we also have something up here. It turns out that x is equal to r cosine theta. So I can replace that x with r cosine theta. So this is going to be r cosine theta. Okay, and so long as you don't have any x's or y's left, then you're pretty much done. So that is our final answer. Final answer is r squared minus 6r cosine theta equals 0. Okay, let's take a look at another one. I want to take a look at this one because it looks very simple. It almost looks too simple that it throws students off. So let's convert to polar form. Okay, so suppose that you have this equation. Okay, so again, so long as you keep in mind that you need to somehow replace your x's and y's with some form of r and theta, then just kind of focus on that. Okay, so right over here, so I need to replace the y. And if we look up here, the very top, we can use this. Y is r sine theta. Okay, so I can replace that y with r sine theta. And when I look at this equation here, I no longer have any x's or y's, so I'm done. Okay. All right, let's go the other direction. Let's take a look at converting polar to rectangular. Okay, so we're still going to be using those equations that we wrote up above. Okay, so let's start off with a point and then we'll take a look at equations. Okay, so let's convert this point. So this point is polar. So this is r and theta. Okay, and let's go ahead and convert this to rectangular. Okay, so so we have r and we have theta. So, and we want x and we want y, right? So we're going to use these. We're going to use the fact that x is r cosine theta, and we're going to use the fact that y equals r sine theta. And that's how we're going to get our x and our y for our rectangular. Okay, so so x equals r, which is 7, times cosine of 193 degrees. Make sure your calculator is always in the correct mode. If you're punching in degrees, make sure your calculator is in degree mode. If you're punching in radians, make sure your calculator is in radian mode. Okay. All right. And then punching that into your calculator, you should get negative 6.82. And then over here, y is equal to r sine theta. So 7 times sine 193 degrees. And when you punch that in, you should get negative 1.57. Okay, so my final answer, my rectangular points, are going to be negative 6.82 and negative 1.57. So that's how you find your x and your y. This one's more straightforward. The thing that makes it tricky about going the other direction, rectangular to polar, is that angle. Again, when you use tangent inverse, because you might have to make adjustments if your angle is in quadrant 2 or 3. Okay, so that's converting a point to rectangular, polar point to rectangular. Let's take a look at equations. So let's go ahead and convert to rectangular. And suppose that I have this equation, r equals 4 cosine theta. Okay, so here, so now it's the opposite. We don't want any r and we don't want any theta. Our theta here is attached to cosine. Okay, so so here we're going to replace r and theta with equivalent x's and y's. All right. Hold on a second. I'm not plugged in. I don't want to lose this recording. Okay, here we go. All right, so again, if you look back to the relationships again, the cosines and all of that, I don't want to scroll up, but if you look at those, okay, so we need to replace the r, okay, and we have something for r that's in terms of x and y. We know that r is square root of x squared plus y squared. Okay, so I'm going to replace that r with x squared plus y squared. And then is cosine theta is x over r. Okay, so we're almost good. Okay, so we're almost good here because we have a lot of our x's and y's now, but we do have that single r left. Okay, so right here, that little r we need to replace. And again, we do know r is equal to square root of x squared plus y squared. So let's replace that r with square root of x squared plus y squared. Okay, so I've replaced the r. Okay. All right, so I've replaced the r here, and we don't have any more r's or thetas, so we're actually good. So this is actually pretty good. If you multiply both sides by square root of x squared plus y squared, that would be even better. It would come out a little more clean. So x squared plus y squared equals 4x. That's if you multiply both sides by square root of x squared plus y squared. So this is actually a little bit better. If I were giving you a non-multiple choice test, I would take either one of these answers. So make sure you do your homework on WebAssign to see which answer they prefer. I'm not sure if they're good with, so long as you don't have any r and thetas, you're fine, or if they want it to be as cleaned up as possible. Okay. All right. Let's see. Let's do this one. Okay, so this one here, r equals 4 cosine theta. Let's do another one. Let's do one more. Let's do an equation. And let's do this one. Convert to rectangular. R equals 2 over 1 plus sine theta. Okay, so here you need to get rid of that r, replace it with something, and you need to replace that sine theta with something. Okay, so why don't you go ahead and try this, hit the pause button, and then come back and see if you got the same answer. Okay, so this would be good. Okay, so looks a little messy if I add if I multiply this fraction on the right by x squared plus y squared square root. If I do this, let me show you. So I want to kind of cancel this fraction here. So I'm going to multiply everything over here on this side by x squared, square root of x squared plus y squared. But that means I have to multiply this one as well. And also up here. Okay, so what I'm essentially doing here is multiplying the right side by 1 written in the form of square root of x squared plus y squared over itself to get rid of that. Okay, and so like I said, that would probably be okay on one of my non-multiple choice tests, but your test, I believe, will be multiple choice. Okay, so so here we get this in the numerator, and then we get this over here. Okay, and this would be fine with me. Okay, you could simplify this further and get x squared plus 4y minus 4 equals 0, but you know, that's okay. All right, so that is pretty much it for 8.1. So make sure that you are familiar with these equations here at the very beginning, these ones right here. Okay, so these relationships here will help you with the conversion process. Okay, again, make sure you email me or message me through the Remind app if you have any questions. We have one more section, 8.2, and that will wrap it up, and we will be taking our second test.